Hello students, today we will discuss some important organic reaction and its mechanism. Already we have discussed in the mechanism in the last two lessons. The remaining organic reactions and its mechanism we will discuss on today. So now we will discuss hydrolysis of ester and electrophilic substitution reaction. Here hydrolysis of ester, already we know that when ester hydrolyzes in presence of water and acid catalyst, in presence of acid catalyst and water, producing carboxylic acid and alcohol. This is called hydrolysis of ester, that is called acid hydrolysis. In presence of acid and water, ester hydrolyzes to carboxylic acid and alcohol. What is the mechanism? The mechanism is same as your esterification. The mechanism is like this. Here first step, ester. If you draw the structure of ester, this is your ester structure. Then this ester H plus, that is called protonation. That is called protonation. Addition of H plus. Here, as it has a lone pair and carbonyl group, will take H plus ion. Then produce protonated ester. That is called protonated ester. Protonated ester will form. And this protonated ester, it is unstable. What happens? It attacked by water as a nucleophile. Water attack. Okay. Then what is the structure when water will attack? The structure is like this: CH3, COH, then O, C2, H5, OH, OH, now cross. Then what happens here? That proton transfer takes place. This proton then transfer to this oxygen. That is called proton transfer. This is called proton transfer. Proton transfer, and it is nucleophilic addition, that is attacking of nucleophile to this carbon carrying positive charge, partial positive charge. Then the step will be CH3, COH, then O, C2, H5. Here it will become H, become plus, because when proton transfer to this oxygen, oxygen become positive charge. Then productive OH. Then what happens? Here O2OH, out of 2H, one will lose one proton. Here that is loss of proton. Loss of proton occur. Then product will be CH3, C. If you take this one plus, then product will be COH, then double bond O. Plus, when it will attack, when this OH bond will convert to pi bond, then this will break simultaneously. This will break so that carbon satisfies the tetravalency and alcohol will be removed. So this is the mechanism of hydrolysis of ester. But if you see the saponification, regarding the saponification mechanism, just same mechanism, but here H plus attack to oxygen. But in case of saponification is like this. You take ester in presence of base. Here C double bond O, OC2H5 attacked by OH minus. This is called saponification reaction. Then what happens? Your base attack this carbon. So it will be CH3, CO minus, then O, C2, H5, then OH. This one. Then what happens? Then this negative charge delocalize towards carbon and loss of C2H5O minus. Then it will be, the product will be CH3, C double bond O, now OH plus C2H5O minus. Then this one, in presence of water, it will be converted to C2H5OH, and as we have taken base, this one in presence of NaOH convert to salt, CH3 COO Na. So in saponification, ester hydrolyzes to produce sodium salt acid and alcohol, and this is called saponification. First attacking the OH minus to the carbon double bond to carbon having double bond, and that is nucleophilic addition takes place. When nucleophilic addition takes place, then the loss of C2H5O minus, and in presence of water, it becomes C2H5OH, and this one carboxylic in presence of NaOH convert to salt. So ester hydrolyzes in presence of base produce sodium salt acid and alcohol. This is called saponification. So this is regarding that hydrolysis of ester. Now let us discuss the mechanism of electrophilic substitution reaction. Let us take one example, chlorobenzene. This is your chlorobenzene. Suppose one substitution is halogenation, that chlorine in presence of aluminum chloride. This is called halogenation, electrophilic substitution, halogenation. Your product is chlorobenzene, para dichlorobenzene plus orthodichlorobenzene, and this is your major product. This is your major product. Let us discuss the mechanism of this para. So here what happens? Your chlorine presence of aluminum chloride. As aluminum chloride is a Lewis acid, it has vacant orbital. It accepts Cl minus from Cl2. The result is Cl plus AlCl4 minus. That means chlorine dissociated in the form of Cl plus and Cl minus. Cl minus will be taken by automatically when aluminum chloride will be in the presence of Cl2. Cl2 dissociates in the form of Cl plus and Cl minus. One Cl minus accepted by LCl3 forming chloronium. This is called chloronium ion, which is electrophile. Acts as electrophile because electron deficient. Then what happens? This electrophile will attack in the second position this chlorobenzene. Then if you see, if it attacks, you already know chlorobenzene is ortho-para-dating group. In para position, you see if you attack at a para position, you have to bring like this. Then Cl plus. Then Cl plus will attack which position? This position. Then result will be chlorobenzene. Then it is plus H like this. Then already here chlorine will attack, already hydrogen is here, then undergo resonance, here resonance occur, this. Here plus sets, then double bond here, then Cl and H. Here double bond here, then it will move here. Here it is plus charge, then double bond, Cl, then ClH. That means if you see this structure has resonance structure. It is equivalent to which one? This, that chlorine, and the positive charge is circulating throughout the ring, so it becomes plus charge. Here chlorine is there and hydrogen there. Then what happens? This will lose one H plus. H plus will be because as the benzene carry positive charge, so it will accept the bonded electron from H because it is a weaker bond. So the product will be Cl. Then already Cl will be attached here. Then if you see, you can draw these structures. So this is the para substituted dichlorobenzene. But if you want to substitute ortho, you have to break at this position. This position break, then Cl plus will attack. So in this way, this is called halogenation. This reaction is called halogenation. This is called halogenation. So different types of electrophilic substitution takes place. Nitration. Nitration by NO2 plus will attack. Then Friedel-Crafts alkylation. Your R plus will be used. Then nitration, that Friedel-Crafts acylation. Generally RCO plus will be used as electrophiles. Then halogenation, nitration, alkylation, acylation. Then sulfonation. Here electrophile is SO3. This is produced mainly from sulfuric acid. It is produced from that acetyl compound containing acetyl group and your aluminum chloride. Here alkylation, haloalkane and aluminum chloride. Nitration generally takes place presence of nitric acid and sulfuric acid produced. These are the electrophile produced during the combination. This electrophile attack to the benzene having pi electron. And which position it is attacking, you have to distribute the electron, you have to shift the electron accordingly. If it at para position, you have to shift the electron from here. If at ortho position, you have to shift the electron from here. So you have to see, and what are the electrophile? Halogenation means halonium ion, chloronium ion, bromonium ion like this. Nitration NO2 plus, alkylation R plus, and your acylation RCO plus, and sulfonation SO3. These are called electrophilic substitution reaction. You have to take care at which position you want to attach the electrophile. You want to substitute the electrophile in place of hydrogen. Okay. Then next we will discuss. You finish this one. Next is cannizzaros reaction. In cannizzaros reaction, what happens? Aldehyde ketone having no alpha hydrogen atom reacts with concentrated alkali forming alcohol and carboxylic acid. So this is called cannizzaros reaction. Here let's take formaldehyde having no alpha hydrogen atom, 2 molecules of formaldehyde reacts with base NaOH forming HCOONA and CH3OH, that is alcohol. All cannizzaros reactions generally takes place in presence of concentrated NaOH, and the aldehyde or ketones should have no alpha hydrogen atom. You see the mechanism. Mechanism will be like this. First, what happens? This aldehyde H, this is your aldehyde in presence of OH minus now acts as a nucleophile. So it is called, now we can say it is a nucleophilic addition reaction, attacking of nucleophile and breaking of bond. So result is HCO minus and here OH and H. Okay, this one in presence of another formaldehyde HC, your double bond OH, this is another formaldehyde. Here what happens? Hydride shift takes place. Hydride shift. Here this bond, this lone pair convert to pi bond, then this will be removed as H minus attached to carbonyl group as a nucleophile. Now H minus, that is hydride ion, acts as a nucleophile for the second step. So what happened to the result? H C double bond O, now OH plus, now H is added, so CH3, breaking of oxygen, then CH3O minus. Okay, then if you see CH3O minus, here we can say transfer of hydrogen resulting HC double bond O minus. Here H can be transferred to this, or in presence of water you can write remaining is CH3OH. So this is the product. So here when it shift H plus to this, it form double bond, then I'm breaking up this. If you can write like this, OH, so like this, the H will be added to this. Transfer of proton from acid to alkoxide, forming alcohol and that carboxylate ion. So this is the formation of aldehyde to acid and alcohol. That is called self-oxidation reduction. That's why it is called what? That disproportionation reaction. It is also called disproportionation reaction. All aldehyde having no alpha, benzaldehyde also gives benzaldehyde. It has no alpha hydrogen atom. This is alpha position, no hydrogen. 2 molecule reacts with base NaOH. Product is carboxylate ion and alcohol. Alcohol is benzyl alcohol. This is called cannizzaros reaction. Okay. Then Aldol condensation. In Aldol condensation, generally aldehyde containing alpha hydrogen atom, 2 molecules of aldehyde reacts with dilute NaOH, forming condensation product is like this. This is called beta hydroxy aldehyde. And from this also it undergo elimination minus loss of water molecule produce that is alkene. enol. You can say it is a enol. Enol. Enol means alkene is there and aldehyde is there. You can say it is a enol. Okay. What is the mechanism? Let us discuss. First step, what happens? This CH3 CHO in presence of OH minus. Now OH minus acts as a base. As it is alpha carbon having alpha hydrogen, and alpha hydrogen attached to any electron within group, that hydrogen will acidic, it loses H plus. Then it becomes CH2 minus, then CHO. Then minus water will be released. OH minus H plus water. So this, that is one conjugate base, is produced from aldehyde. It mainly takes place in presence of strong base. So CH2 minus CHO is produced. This CH2 minus, what happens? It attack to another aldehyde having partially positive center carbon. So this will attack to this position. The result is CH3 CO minus, then CH2 CHO, already hydrogen is there. Okay, it is produced. And here what happens? In presence of water, it becomes, in presence of water, protonation takes place, that is CH3 CHO minus become OH, then CH2 CHO. Here this loses water molecule, it loses water molecule, that here hydrogen remove. How water remove is removed? Here CH2 loses one H plus, then become minus charge, then become double bond, then OH is removed. So like this, loss of water from H from here, alpha carbon H and OH, both will be removed and produce CH3 CH double bond CH CHO. This produce. So first important thing is formation of conjugate base which acts as a nucleophile. Then it is called nucleophilic addition to the second group, attacking to second group at carbon, at partially carbon positive, partial positive carbon, and nucleophilic addition reaction takes place. Then protonation takes place in presence of water. Protonation, where generally protonation occurs? In presence of water. Water donates H plus to O minus, forming hydrox, that is alcohol group. Then alcoholic group and adjacent alpha position hydrogen both remove, OH and H remove, forming double bond. So this is regarding the mechanism of Aldol condensation and cannizzaros reaction. But important thing is sometimes cross Aldol condensation takes place. Very important thing is from where the hydrogen is removed and producing conjugate base. The hydrogen removed where alpha hydrogen is available, and towards in the adjacent to alpha hydrogen it should have more electron withdrawing group. If electron withdrawing group is there, then it can produce H plus ion and it itself acts as a nucleophile in the second step and attacking the keto group. Already know aldehyde ketone shows nucleophilic addition reaction, then attacking the nucleophile. So in this way, you have to think which mechanism will be applicable, which mechanism will be suitable, and it depends upon the nature of product. You have to think accordingly. Okay? Thank you all.